The third quantum number is based on the directional angular momentum. The directional angular momentum is how much a thing is spinning around a given direction. And usually we consider spinning where the direction is spinning around the z-axis. How much is spinning around the z-axis? And the third quantum number is the directional angular momentum quantum number. And the most typical letter for it is ml. And to understand ml, the key is to look at the dxy orbital and the dyz orbital. Can you see that in these two pictures here, which I put check marks? They are both clover leaves. In a clover leaf, it takes how many lambda to make a full circle? In a clover leaf, it takes how many lambda to make a full circle? Put it in chat. And the answer is it takes 2. L equals 2 in both cases. These are both d orbitals. But we're no longer interested in the number of lambda it takes to do a full spin. In the directional angular momentum, we're interested only in the question about how many times it takes to make a full crest to crest around the z-axis. So in the case of dxy, the answer is you can get 2 in. But in the case of dyz, how many lambda can you get in? Put it in chat. And the answer is lambda equals 1. You can only do 1. So from the point of view of the z direction, the amount of angular momentum you can get in the dxy and dyz is different. In the case of dxy, from the point of view of the z-axis, which is the axis coming straight out, you can get 2. And so ml is in magnitude 2. And in the case of dyz, it's 1 lambda, and ml in magnitude is 1. And I say in magnitude because it turns out that clockwise rotations and counterclockwise rotations are of opposite sign. So when ml in magnitude is 2, this means ml could be equal to 2 or minus 2 or some combination of the two. And ml equals 1. Magnitude means ml is equal to 1 or minus 1 or some combination. And that is the connection then of the third quantum number ml, which is the directional angular momentum around one direction.